Me. Good morning to all of you. I don't hear anything, but I suppose that is the normal way of working here. So,
Good morning, and we are seeing you very well, Edvig, without
yes,
any
thank you.
problem.
Hi, Pepe. Okay, and all the colleagues there in Cuba, good morning, because for you it is still morning, whereas here we are already reaching the late afternoon. So, as Mark has indeed indicated, I will try to present you the ABCD software, but not that much the ABCD software as such, since I'm not the right person to do that. In fact, the right person is amongst us. It is Leandro Tavares Martin, who has been leading a team at the UCI to develop the ABCD3 software. But I think it is better for me to focus on one specific aspect of the ABCD3 software, which is what I call the documentary layer of it, which means I will not look that much or even at all to the administration um, functions of the library system, not only because me myself am more interested into the documentary parts of the system, but I think that the documentary part has not been having highlighted sufficiently up to now in the past of our ELINF project. And when later on, as I will try to help you by introducing you to the IDs, if you later on have to decide on how to go on, how to proceed, also looking at, for instance, Polaris, which is another software environment, I think in order to be able to make a good comparison and to make a good choice, a good decision on that, you need to know more about that documentary level or the documentary layer within the ABCD system. For that documentary layer, I will always refer to what we call JISIS, or for you, para ustedes en español, JISIS. But let me just use the English name JISIS. I will do that using a presentation which is available actually on your Moodle course pages. I have put some 3 documents there, but it is the PowerPoint presentation which I'm going to follow here, which I'm going to use to introduce you to the JIC system. And hopefully, by doing that, helping you in making a better decision on the future of ABCD. So let me try to share my screen with my presentation. That should be it. If all is well now, and maybe someone can confirm, you should be looking now at the first slide of my presentation on JISIS, the
Yes,
documentary.
it's okay.
Okay,
Okay, yes, okay.
all right. So,
At least in Havana.
yes, well, Havana is the center of the world, so what else matters? But as you might see, I have 29 slides. The last part of them are actually efforts to show functions of the system itself, which I might try demonstrating by using the software itself rather than the presentation here, which are screenshots. But it is important to note that you can have this presentation downloaded yourself. Plus, even more importantly, you can also download the software. In my presentation, I have therefore added quite some links to where you can download all necessary components of the JIC software. I repeat, My links will only be pointing to JIC software and underlying technology, but not to the ABCD 3.0 system as a whole. I will try, however, to explain a little bit about how those two environments relate. What is the position of JICs within ABCD 3.0? If the idea was supposed to be that this should lead to a discussion on ABCD itself, I can simply put in front of everything else that I think the non-JICs part of ABCD, so the part which I call not the documentary part, but the administrative database part, is a little bit more familiar to everybody of you there. It's a typical PHP, not MySQL, but PostgreSQL application. And I think most of you might be familiar with that. And it's not that much special, except for being well done by the team led by Leandro. But I'm not going to highlight that part. So let me continue with my own presentation, which is indeed about JICs. By the way, if you want to see more of that presentation, I have added quite some notes into the presentation. So let me quickly show you. If you look at the notes, so you see you don't have to take the notes yourself. It is all there already. So very briefly, I will just point to the fact that indeed there is some history behind JICs. It doesn't come out of nowhere, out of the box. It is a follower up in a historical sequence of software developments. But I don't need to elaborate on that for too long. Maybe more interesting is to look at the basic technological elements to give you some appetite, in fact, to see that, okay, there are lots of interesting technological elements present in this software. And then, as long as time allows, that is the third part here, I might do some demo of some of the more interesting functions of JICs. But I repeat again, if we can't reach that stage due to time constraints, I would just invite you to download the software yourself and to try things yourself because it's all available for free. It's open source free software. Now, pointing to the history, this is a picture summarizing the whole history, which is mostly a software developed within the United Nations environment. It has a history which is already decades old. It started decades ago in the International Labour Organization, which you can see on top of this picture. And again, I don't need to go into all those steps of the development, but as you might see towards the middle of the picture, there is a lot of work done by UNESCO, who was and has always been the biggest promoter of the software, with the aim to support countries who could at that time not afford to buy commercial sophisticated library software to still try to do automation of documents and libraries with the good software dedicated for that purpose. So, but in a free way, at that time it was still not open source. That is a later development. But that was the main aim of UNESCO to assist countries in developing their information management skills by providing the software. What is important here is to look at the bottom where you will see JICs mentioned at the left side, ABCD in the middle, and then in between ABCD and JICs. And I started this already in 2015. So that is quite some years ago. But that is where we have to situate ABCD 3.0 as something like a marriage, a combination of the ABCD software, which is fully based on ISIS technology, now using JISIS as a documentary database layer. So it's a family of software, but okay, it's just to show you that we are not alone and there is a richer history, which is in fact repeated in this second history slide. By the way, if you are interested in the ideas of UNESCO, on this slide in the middle part, you will find a link to the UNESCO web pages about their free and open source software support. Now, one of the people working for UNESCO, and his name is Jean-Claude Dauphin, he used to work because he has retired by now. He started the development of JISIS, and it is now available at GitHub. We will see more links to that later on. In order to keep ISIS with current updated modern computer technology, like for instance 64 bits, all using web technology, things like that, which were not that much available before. Currently, JISIS dates the last version which has been published, which has been released, is slightly over 1 year old, so February 2020. And there you can see the link and you can download the software from there. What you need to have installed before the JIC software will run is the Java JDK FX. So it's not only the Java development kit, JDK, but also FX, which is an additional set of libraries to add even more rich interface elements. It was a little bit difficult to find a good place to download such combined distributions. In principle, you can download the JDK and then download FX as a separate unit, but then it is a bit cumbersome to integrate those two. But at this link of Azul, maybe it is without the www. I'm not sure about this, but you will probably find it if you just try azul.com downloads. You will find lots of Java JDK packages and also the ones with built-in FX modules. And that is what you will need if you want to run JISIS. JISIS is a desktop application, but it's a fully client-server structured application with integrated web server and browser. So it's not just a simple desktop application. And that is what I think is a very useful additional software which should be combined for ABCD 3.0 managers. Whereas ABCD 3.0 itself is only using the JISIS server. So the part of the software which has all the functions, but without the interface. If you need the interface to interact yourself, you use either JISIS Suite or you use indeed ABCD 3.0, which in a way is an interface using the JISIS functions. Okay, all the sources and documentation on JISIS are available also on GitHub, so we can go a little bit faster here. Again, this is a bit about history, but it is not that much important. The old classic ISIS, it was not Unicode, and we thought it is necessary in an international modern development to turn everything into Unicode, certainly because the United Nations also have to support countries outside Latin America, outside Europe, where they use indeed non-Latin alphabets like Arab, Chinese, Indian languages, Amharic in Africa, things like that. And for that reason, the Unicode development was very important, but is fully already part of Java, as some of you might know. So that was one of the reasons why UNESCO decided to start using Java for developing the Java ISIS. Others, Other problems related to the old classic IC software are related to limits built into the software, like record limits, the maximum size of the records. It used to be 32 kilobytes, which is quite okay for bibliographic records. But as you will see, we are now more interested into more factual data and full text applications. So even the 1 megabyte limit, which came later on in classic ISIS, was not sufficient. In the current JIC software, such limits no longer are there. So we use actually the Berkeley DB NoSQL storage layer, and there are no limits except for hardware defined limits. So databases can be any size, records within databases can have any length. But it is still IC software, even if we changed some fundamental options. It is still really IC software, as we later on will see, because the main defining software typical elements for ICs, like for instance the formatting language, and I hope I can briefly show you what it means. The formatting language for ICs is exactly the same as in the old previous releases of the software, but has received some more features based on web technology. I hope I'm not going too fast. I also hope for you, Spanish people, Spanish speaking people, that my English is not too difficult to follow. So I'm trying to articulate carefully. But since I have no feedback, it's a problem of this online environment. Let me just continue and presenting the technology which is used in JISIS. I don't think I need to introduce you to Java, which is very powerful. Everybody will agree on that. It is platform independent, but there are also criticisms. Like I have read about security issues. People have already announced Java is dead, but I don't agree with that if I look at how many big projects still are running on Java. Um, Programming environments are there, NetBeans, Eclipse, as most of you, I hope, have already seen or know those quite famous programming environments. They are all there for Java as well. Java has lots of libraries and modules. It has Java servlets with servers like Tomcat or Jetty. And then in the case of Java ISIS, we use also additional functions which are only available using the FX additional libraries. So that is why I mentioned you need to install them as well, or you need to install Java JDK with that FX part built in from the azul.com website. The Berkeley DB storage layer, it is as all other software here we use, it is FOSS. It is NoSQL, and maybe I should briefly explain something about that. And it is mostly used, and they claim they are the most widely used database in the world, which is quite a statement, I would say, but they are very widespread in the Internet of Things, so embedded in all types of small devices where little bits of information need to be stored. And if you look at the Oracle pages about Berkeley DB, that is their claim. So it's not just a strange even if it is not a very well-known database like MySQL or Postgres, but it is according to their own statements, it is a very widely um, storage database tool which uses the NoSQL, the NoSQL uh, philosophy, which is actually very simple without all the relational features, which in many cases are not that much necessary. And without using those unnecessary elements, you can have benefits in speed and scalability. That's basically the philosophy of NoSQL. Drop the idea of tables, put everything in one big table, like Google does with their own database, which is also using the NoSQL philosophy. Then the third important part of JIC's basic technology is Lucene, which comes from the Apache Software Foundation, which is a full text indexer. So that is a tool which will allow to do retrieval of all elements within large text documents, um, including a ranking mechanism. If I'm not wrong, then that might also be confirmed today, later on in the second presentation, or tomorrow. Also, the Polaris system uses Elastic software, and I think, if I'm not wrong, also Elastic software uses some kind of Lucene indexer. So in that way, we are part of the same tradition or the same family. Let me skip this slide because this is only interesting if you were using before the WinIC software, which is the predecessor, so the previous version, which became very popular due to UNESCO support all over the world, let's say the developing countries there. But we are not that much um, indebted to WinICs, but still quite some options in JICs have been taken because of being present, being used in WinICs. And the idea was to serve existing WinICs users with everything they could do in WinICs. They should also keep doing that in JICs, but then adding, of course, quite some new features of new software technology. Um, Maybe important to notice that there is still compatibility with those ICS databases of previous version. There is a feature to import from exported ICS databases straight into JICS, so that existing ABCD users, for instance, can also move to ABCD 3, which uses JICS, by using the JICS import wizard. The existing limits, as I already mentioned, have been dropped, so no more database and record length limitations, which now allows also the use of full text documents, so the what we call the digital library features into JICS and ABCD 3.0. Important is to note the flexibility which is offered by NoSQL. Flexibility in the definition of information structures. There is no longer a need to structure all your information elements into square tables where the structure has to be exactly the same for each of the records of the elements in the table. But instead, we focus on flexibility to allow for inclusion of very different and differently structured records into one or different databases, which means in one single database you can put any type of information, but if you prefer, and that is what we mostly do, You can also organize your information in different databases, all dedicated to different types of information, but then in a semi relational way, we can link those databases in one view. So that is what we call a semi relational runtime feature. So when we produce the screens with the output of the databases, we can get those data from different databases, which is a bit like a relational approach. Okay, the most typical elements of the old IC software are still there. So we have a field definition table, that is the FDT acronym there. You have the FMT, the forms, the form tables for data entry. You have the FST, the field select tables to configure your indexing and therefore your searching possibilities. And then finally, you have the PFT, the print formats of ICs, which allow you in a far reaching way to define without any real programming, but just as a user of the software, you can define using the formatting language exactly how the data are extracted from the records and how they are presented on the screen. So we call it the print formatting, but of course it is more like presentation formatting because it can be presented on screens, on web pages, on any type of output. We now have a lot of HTML features also allowed, and since JICES has a built-in browser, everything you do in HTML coding can immediately also be used within JICES. For the librarians, we still have the old but very much demanding Mark 21 criteria or requirements. That is mostly for historical reasons, whereas I think also libraries are moving out of that old technology, but still there are international agreements to continue using Mark 21 formatted records, to use shared cataloging with, for instance, Library of Congress, with that norm that is an international protocol Z39.50, which is about shared cataloging to copy records from existing catalogs, for instance, Library of Congress in Washington. So those are important features for the librarians, for bibliographic information management. And of course, all that is still there because it is still the core business of JICES as well as ABCD 3.0. Okay, still doing the overview of what JICES will offer you. You have a database creation wizard, which means you can create your own databases, and that is an important invitation because I think a modern library system should not only offer the existing catalog database, which probably will be Mark 21, but I think that libraries and especially in universities and bigger institutions, they should also produce their own smaller databases with all types of locally relevant um, documentation, information like factual databases. And the JICES environment perfectly allows you to do that yourself. In reality, there are lots of such models already available. Like, for instance, if you want to do a database on experts and build it up to become something like a research management system, there will also be models available for research projects, for reports, for events. And as mentioned before, you can all combine them together into one system. So then I think I'm pointing to the more interesting part of JICES, which I hope will also be considered when talking about ABCD 3.0. because all this is already available in JISIS, and therefore I think we should consider at least the option of enriching the library system to become something much more powerful, much more encompassing, dealing with much more different types of information. So to present the library as an information management agent and not just a bookkeeper. Okay, I'm looking at the time, which is going fast as expected. So I'm not going to go into any details on the technology of JISIS records, but just note here from this slide that differently from the old ISIS, by the way, JISIS not only focuses on ISO 2709 records. ISO 2709 is the old standard for MARC, so bibliographic based databases. It's a very smart technology, if you ask me, because it is actually an idea which came long before the idea of fingerprinting documents into document systems. But ISO 2709 actually does fingerprinting, but not on the contents of the record, but the structure. So it notes down in a numeric directory which fields are there, how long are they, and where do they start. So at which offset of the record will you find each of the fields listed in the directory. That means, and that is why I call it smart and performant, the only the directory needs to be parsed when opening a record to see what is in this record, and immediately all the elements can be retrieved. But also, even more importantly, each record has its own structure, and that is the flexibility which I explained. Each record can indeed describe who am I, what will you find if you open me, and therefore there is no need to have records uh, following the same structure, and you can mix all types of records into one or several databases. That is what the old ISIS could do. We can still do that with JISIS. So JISIS fully supports that old model, but we can also add blobs, so binary large objects, for instance, for images, for movies, for sound files, which can be part of the database, so they will be stored within the database. We can also deal with XML and JSON structures. That is also becoming more and more important. And then finally, the last type of records, which I think I should mention, which can be part of JISIS, and therefore they can also be part of ABCD 3.0, which is up to now not at all the case, but I'm just mentioning it again and again. It is perfectly possible to have full text documents parsed by a Tika library, which will deliver the metadata plus all the text contents of the documents. And then JISIS provides Lucene full text indexing. So actually, your full document system can be made retrievable in the same interface as your bibliographic data. Now, more practically, I already mentioned this, that you can download the February 2020 version of JISIS from the link given here. In fact, it comes as a set of folders, so you don't even have to install it, you just unpack it, which means it will be a set of folders in your file system, and then you have to do a little bit of configuration. Other modules are already there. Lucene is there, Tika is there, Jetty, so the servlet server is embedded. Mark modules are there. Everything is there in the package, which you can download from GitHub. And all you have to do in the little effort of configuration is to put the path to your database home folder. Of course, there is a default one in the package already, but if you want your databases to reside in another folder, you can do that in the dbhome.conf text file. So it's a simple text file. There is a text file server.conf where you can put the port number. If you use JICs as a desktop, you will be using most probably the 1111, so the 1111 port, which is just the default port, but you can change that yourself to connect to any servlet server for a JIC. So it's a full client server application. And then finally, in order to link JICs to your JDK with FX, you have to indicate it into the jics_suite.conf, which is again a small text file in the package you have downloaded. After that, you simply run the launcher, and I'm now going to switch to a live demo. I think I have just a few more minutes left, but maybe for the remaining part of the presentation, I will quickly show you that the presentation is just now remaining about screenshots of the software, whereas I think it could be better to simply look at the software itself. So here's some more information about the installation on the web JICs. That is still another part. It's a web interface on JICs showing the setup of ABCD 3.0 in the same way. It's a web interface on the JIC server exactly as ABCD, but without the library functions, because those you will find in ABCD 3.0. Okay, and then you have the screenshots here to open the connection, open database. You can browse databases in different ways, in table format, in document format. You have data entry forms. You have editors to define your indexing, your print formattings, your worksheets, all that is there so that you can do this type of work in JICs without even using ABCD. But if you do that in JICs, the forms and the tables created will be available through ABCD3. So they can go together very nicely. Searching is available. There are editors for all those tables which are interactive. So, and if you need to know more, you can consult the manuals about that. Quickly, okay, here you can see an image as part of a record. So the blob, the picture itself, is stored within the record, which is also interesting if you want to do, for instance, museum applications. The digital library is about full text applications, so I'm continuing here. I think I'm almost at the end here. There is an additional Groovy programming language, which broadens even the possibilities. So the sky is the limit if you are really ambitious. Within your print formats, you can do some smart additional tricks using Groovy Java-like programming. WebJICs, I've already mentioned it. It can also do data entry. It can also do searching. But here, finally, we are at the end where we will find more links. There is a users community where you can put questions and hopefully get answers. There is the GitHub environment. Here is the latest JIC suite release for downloading it. And then also the documents. There is a PDF, but I've put it also available directly in the Moodle course. So now, having only a few minutes left, I would like to continue with a very brief demo, which means I have to share my screen. Let me go to another part of my screen where hopefully I can still find JIC software. No, this is the, so I have to go back, sorry. I took the wrong choice from the list. Be careful then. Okay, this should be okay now. This is JICIS after having opened it. I'm afraid the font which I used is not very easy to read for you. So I can once more invite you to download the software for yourself so that you can run it on your own desktops. Here I'm opening a connection which by default uses that 1111. So now I have connected the client, which is my JICIS interface, to the JICIS server. That's the same server used by ABCD 3.0. Then you open out of a list, for instance, a database here. Let me just take one of the many demos, but uh, honestly speaking, many of these databases are not that well prepared. So it's not always that interesting to look at them. Okay, here is one record of a bibliographic database, which doesn't look very interesting, but the interesting part is at the bottom because this is a database for a museum where you can see that also the pictures or the objects of the museum are stored inside the database. Since it is a web browser here, we can have the links. You see the typical hypertext links, and then the picture shows up here in a separate window and can be viewed in a larger, or maybe you are not seeing that window now because I'm only sharing my JICIS window, but JICIS will open a pop-up window to show the picture in more details. That is one example of bibliographic data combined with blobs. Another database which I would briefly, but just finally, uh, prefer to open is the digital library example, which we provide as an example here. Let me look carefully for digital library example, this one for instance. If I open this database, okay, you see here we have a full document. This is actually a manual on WinISIS. So the whole document is there, but interesting is to note that it has been automatically loaded into the database using Tika text extraction, also for metadata extraction. You can search this in a full text way. So let me go to the search interface for this database because I have two databases open at this time. And if I say I want to know about WinISIS, you see there are suggestions here from the index, and then searching on that word will give you all the documents or all the records in this database, which are about WinISIS, as you can see with the search keyword highlighted here in your document. So this is a very brief demo of JICIS, but I see my time is up. I would like to quickly return to my final slide in the presentation because I think it is still important to know where are we now, what was the idea of doing all this. I thank you for your interest indeed, but let me point out that you have to make up your minds, and that is actually the whole idea of this presentation. You are the Cuban ELINF community interested, or at least focusing on the ABCD software. And in view of the recent developments, like for instance, my fear is that the JICIS developer is fading out his efforts. So if it needs a future in Cuba, for instance, it will be you to adopt the software, and not only the software, but also its development. So if you like the idea of continue using ABCD 3.0 with JIC's documentary database storage, then I think that you have to fully embrace the software development of JIC, so the Java software programming environment with the Lucene environment and all that, in order to keep it alive and to make it even better. Or alternatively, and that is why in this session there will be also a presentation about Polaris, that could be a new environment to enter into, but that's up to you. I'm not even giving my advice here. I just was requested to present what is the power of JICs and ABCD 3.0 without speaking out my mind on the power based on Elasticsearch in the Polaris system, which will be the subject, the topic of the next presentation. But it is you to decide on which one to go, which direction to take. But the message should be clear. If you choose to continue the existing efforts of JICs and ABCD 3.0, which I think makes a lot of sense because it's a rich, powerful environment, but then you have to fully own it. You have to fully embrace also the software development of that, so to give it a nice future. If not, if you prefer to step into a larger community with a broader development environment, no problem. That is the topic of the next presentation, I suppose. So, Mark, I don't know whether
Thank you very much.
take over from here.
Yes, I take over, but first of all, no, I hope that someone has some questions or some remarks to make at the moment.
Are we doing that this at now? I mean, before.
If there is, we have surely 5 minutes to hear some comments before we can start with the Polaris presentation.
Yeah.
I think
Okay,
it's good
of course,
I don't know if we get some comments. That's another thing.
Well, I am aware that I was too fast. I had too much to present in too short a time. But at least the idea should be there that it is a rich environment which has not yet been fully adopted in ABCD 3.0. So that is my suggestion. If you go for ABCD 3.0, embrace JIC's power. If not, there are alternatives available, but that is an important decision for you to take. And you can't take that decision without having looked at the power of JICs. And that was my topic.
Thank you. Are there at the moment questions, remarks?
Si hay dudas, yo puedo entender y contestar en castellano, no en cubano, pero castellano sí.
Okay, I don't receive at the moment any reaction. Thank you, Egbert, for your strong commitment and your strong appeal for the GISIS environment. The people, most of the people of the project know that in fact ABCD was adopted from the beginning of, even before the beginning of the project in Cuba, I think from 2010 on, something like that. Still, we, as Egbert also tells us now, that it is a very strong software at the basis, the GISIS, but we have some issues because we don't know how to continue without the support of the UNESCO people. So we have to make a choice on that. We have to think about to use the GISs and the possibilities of GISs, or do we have to evaluate if we can continue with it, or do we have to move to other solutions? And as I understood, there are some students from UCLV who will help us with that. We have people of Pinar del Rio as well, who will evaluate in which way we can go. And Egbert, we need also still your experience to follow up this evolution.
Yes, okay. And I think it's up to you and Febe to organize and to direct the discussion on the way forward, huh?
Yes, that's for sure. We have some responsibility.
Yes,
That's
indeed.
true.
As a final remark, except for repeating that indeed I will remain available, but I don't have anything against the Polaris and other alternative solutions. My only purpose was to emphasize that if you want to continue with JISIS, you need to fully embrace it. And you have to also recognize similarities with other technologies like Polaris and Elasticsearch. But it is up to you, and I will support whatever decision you took. I think they are all very familiar and similar solutions, all based on open source and documentary concepts. And so therefore you will have my support anyway.
Thank you very much. I think we can close this first presentation. Egbert, can you close your presentation?
I have to
No.
close the sharing. Okay.
Okay.
Okay now?
Carolina, hello.
Hello, how are you?
I'm fine, and I hope you found the presentation of Egbert interesting.
Very interesting, in fact.
Very interesting. No, it's in a way, Egbert always says this is a NoSQL solution before NoSQL existed. The GIs, the ISIS technology. So
yes, in fact, we invented it.
Okay. Yeah. So on that level, it can be. It was surely. It was also an important aspect of our work in the past. But at the same time, as you have heard, we are at the moment that we are looking in which way we have to continue. So, and as Egbert also already said, he was very interested by the Polaris development because it made him think about the philosophy that was his own when he was working with ABCD, with CDSIs and so on.
Sure, we have several things in common, so of course we are interested in other solutions, for sure.
Okay, so it's your turn now to
Perfect.
To start.
So I'm going to share my screen. Right now, can you see my screen?
Wait. Yes, yes, I can see your screen. I'm looking at the if there is a problem. No, it's okay. There was a little issue with the recording, but it's okay.
Okay, perfect. So you see the full screen. So let's start. Well, hello everyone. I know that some of you know already my science work and Polaris OS because we had other meetings in the last weeks or months. So for those who doesn't know Polaris OS yet, we're going to do a little introduction about our company, about Polaris OS, of course, and also the data mining services that we have. So let's start. My Science Work is a technological company, a French technological company committed to accelerating research, optimize funding, and avoiding duplication of research. Since 2012, My Science Work offers free access to a global scientific platform on My Science Work website that you can see. It's for free available on the website. And it offers more than 90 million publications from 100 of sources and 12 million patents. My Science Work also provides a suite of advanced data-driven solutions for research institutions, universities, scientific publishers, and research and development companies. It has developed Polaris OS 4 years ago, an open source, highly customizable data-driven solution for digital asset management. So it's really versatile in its use as an institutional repository, current research information system, library management system, multimedia archive, or dataset. We will see that after. And also, we offer an artificial intelligence-powered research analytic solutions called Sirius. It's for governing bodies, and it helps research institutions to automate several research activities and their task. So let's move to Polaris OS, which is the only one that data management solutions and can help you with your research activities and to improve open science. So let's see why. Polaris OS is all-in-one solution because it's really flexible and it can be adapted. It can be used as an institutional repository, as a current research information system. It can be also a dataset and an open journal system. I will give you some examples after to show how we can adapt Polaris OS to all these environments. So the platform is one of the most flexible solutions in the market, and is highly customizable. All the graphical layout and functionalities, for example, metadata models, workflows, forms, collaborative features, are in fact customizable. So Polaris OS has been developed as a low-code solution, meaning with little to no programming skills, you have full range to exercise control over the entire installation, management, and updating of the solution. So it was developed on purpose to accommodate and simplify the integration of developments. It's so customizable, so it's also metadata schema agnostic. It means that it's compliant with any schema, and all metadata fields can be configured in Polaris OS. Well, it's also interoperable with other information system, the open database, websites, Crossref, and others. So what about the community? We are a small community, but Polaris OS, it's open source. Its code is shared in GitHub. Open science is at the heart of most My Science Work projects, because the company My Science Work has been born to promote science and open access. So it's one of the most important parts. That's why the solution is in open source. We have a permissive license, and we have a small team. It's composed of 6 expert data scientists, which allows us to easily prioritize extra developments, or it allows us to use the latest technologies to accommodate additional developments. So it facilitates the integration of specific developments effortlessly. Now we are going to see some success stories to show how it can be adapted to be different solutions. As I said, it can act as, or it can be used as an open institutional repository, as we did with INED. We can be also a current research information system, as we do with Deutsche Bundesbank. It could be also be a grant management platform, a data set, and so on. So, for example, for INED, INED is the French Institute for Demographic Studies. It's a public research institute specialized in population studies, and they wanted to set up an open institutional repositories that meet their requirements. So they need this institutional open repository for the scholarly outputs and to give them more visibility around the world. So, well, the mission was large, but to sum up, their goals were to automate the process for archiving their research publications and metadata, to connect it to other existing repository systems, to get a complete analysis and overview of the impact of their research activities, and to promote their scholarly outputs through a centralized dashboard. So the institutional repository of INED manages different types of publications with different versions, and the goal was to get a robust and scalable technical solution. And they can develop new services and modules later, as we are doing actually, because they need several things to be modified or adapted, and we still work with them. So another example, it's a research outputs promoting platform that we did with a laboratory in Luxembourg, and they wanted to centralize their research outputs in a single platform, and also to collect, to clean, to analyze these publications, and to gather all the metadata. They wanted also to popularize their activities by using our scientific journalist services, and to promote their team members by offering expert profiles and social media features. And you can also go to their website, because it's still available on their institutional website. Another project, very different from the others that we have just been talking about, it's the INSERM. INSERM is the French Public Institute dedicated to biomedical research and human health. And they wanted a research project management tool. So INSERM, it's part of the IRDIRC International Consortium, whose members come from more than 40 countries and more than 30 organizations funding research projects. So they wanted to have a service provider. They wanted to contract a service provider of research project information with global coverage, which can integrate the orphaned nomenclature of rare diseases as a controlled vocabulary list to filter projects dedicated to these specific diseases. So it's a very beautiful project, because we have to take into account all the different items that every nomenclature in any different country had. So Polaris was the solution to support the long-term orphaned research platform and the IRDIRC International Consortium for curation and automatic classification of research projects that they found. Apart from filter projects dedicated to specific diseases, INSERM wanted to annotate them automatically according to a predefined list of categories, and also they wanted to expose them to curation and quality control by the orphaned experts. Its automatic classification module of research projects is based on technologies of natural language processing and machine learning that not only automates all scientific data recovery, management, analysis, and retrieval processes, but also integrates with other internal and external systems and databases. Another example is the current research information system that we have implemented for Deutsche Bundesbank. So, well, the Deutsche Bundesbank is the independent central bank of Germany. And the goal here is to set up the Polaris platform to handle all the information and data related to ongoing and finalized research projects, descriptions, research outputs, discussions, papers, and article submissions for peer reviewing into the Bundesbank journals, publications, and so on. So the goals were basically migrate the research projects and publications databases from the current system to Polaris OS, to manage all the publications from submission to acceptation for the Bundesbank journals, provide a flexible API to allow internal systems to access the institutional repository, and also to provide a platform able to embed natural language processing technologies for the automation of tasks and test analytics. So another example, and the last one, is a project that it's an ongoing project that we are doing actually, and it's a grant. It's with a foundation in France, and they wanted to have a grant management platform. So also Polaris can once again evolve in this field and give an answer to the need that the foundation had, because they wanted to have an scalable solution for requesting and monitoring grants. So there was the researchers who asked for grants to get the funds and do a project. And they needed a platform to monitor the submission and reporting process for them to obtain the grant, and to manage the grants, the project funds request, and to analyze and monitor the selection process. So with all these little examples that I have just mentioned, I just wanted to show you that Polaris is the all-in-one solution that you can have. It's also open source, it's a local solution, and you can configure many things with no need to develop extra code. And it can be adapted to be the all-in-one solution that could fit your needs. So until there, the explanation of Polaris OS and the projects. And now I'll give the floor to the technical director of my science work, Manuel Guzman, and he will give a deeply insight about the technology. And so Manuel, please, you can take the lead.
Yeah, thank you, Carolina. So I'm gonna go through the basic architecture of Polaris OS, and then what the flexibility is. As Carolina has just shown, the basic of Polaris OS is the flexibility. So you've seen that there are multiple type of systems and then can be configured or done, and this is basically because you can configure all the forms you use, all the data structures you're going to use, and all the treatment you're going to give to that data in terms of validations or new data generation, or new configurations. So let me just share my screen to start. I think you can see my screen now.
Yes, we see your screen.
Good. So in terms of the architecture, it's a pretty just plain and simple one. We have all the core of the system that is built on Node.js. So a JavaScript engine that actually it's just gaining some field on the development side because of their performance and the community that it's behind right now. All the presentation layer is done with Vue.js. It's a tool that took some ground as well from Angular and React at some point because of it seems to take some of the best of both. And then all the data store is split between Elasticsearch and Minu. I'm going to go a little bit in detail on those, on why we use all those components. But this is the basic structure. Then every other system can also interface with Polaris OS using just the REST API that are exposed on every functionality that we propose. So basically, what's done on the front end can also be done through the APIs with a standard REST API, REST over HTTP, using JSON in the structure of the messages. Now, Node.js, as I said, is where we build all the business logic. So this is where most of the code is in terms of how the application works. And this is where developers could go if they want to enrich the functionality of Polaris OS, knowing that the objective, as Carolina said, is to have a low-code application. Basically, we try to give the users the power to configure themselves the database they're going to use, the type of fields they will use, the validations they will apply to each form, the way the forms are presented, all those kind of things. But we also have from time to time functionalities to develop because we're a pre-join application. Polaris OS has around 3 years, or below 3 years, I think now. So we still have functionalities to add, and we keep adding functionalities to it just to enrich the full ecosystem and how things can work. As I said, with every function we create, there's going to be an API related to it. On every entity, as we call it, which is basically an index for a table that we create, there's going to be a set of methods in the API that are going to be automatically exposed through the API. So people from outside Polaris OS could also use them to, for example, create, remove, update, or just query the entity itself. And we, as every ecosystem of development, we just base a lot of what we do in public available libraries that are available through NPM because of the richness of the whole community and the environment of Node.js itself. So this is very common in all the let's say in all the community languages. So we see a lot of that in things like Python for data science, or Node.js. Before it was Perl. You still see that also in Java. In all the, let's say, community languages, you see this kind of offer. It is very rich in case of Node because of the popularity it's taken recently. In terms of the data storage, as I said, we use Elasticsearch for storing all the metadata of each of the objects, as well as the configuration and the predefined list that we use in Polaris OS. We took the decision at some point to have just one single database instead of mixing two, one for the data and other one for the search itself, just because we wanted to reduce the complexity of the installation and the maintenance of the system. And we consider that Elasticsearch can be used for more than just searching as a search engine. We consider it can be used also as a storage of the metadata, and that's what we are doing at this point. That allows to have data only once, so we don't need to replicate that. As it was said before, it is true. It's based on Lucene behind as the indexing let's say, source. There are many things that are added by Elasticsearch, but the base, it's true, it's Lucene indexes. Now, the advantage of using Elasticsearch is that we know now that we can search on almost everything that we have. If we configure that search well, we can take idiomatic limitations or considerations into account when we configure the search and the indexes in Elasticsearch by putting in place specific analyzers, and that makes then Polaris OS powerful in terms of how we can search and find information. We can also, which is how we install by default, is just to we secure the communication between Polaris OS and I mean between Node.js and Elasticsearch using SSL certificates, just to be sure that the things are protected from end to end. Elasticsearch is an open source. It's an open source software as long as you don't use it to give someone else the service of using Elasticsearch. Basically, they don't want people like Amazon Web Services or Azure or Google, I mean, any of those, to provide the service without Elastic getting any part of that if they provide the service. So in our case, there's no limitation. We can use it because we're not providing Elastic as a service at the end. So it's an open source. There's some people that will tell you it's not open source because they have gone against this option of letting everyone do whatever they want with it. It's basically the same move that some years ago MongoDB did for the same reason. It's just they say, well, if someone is taking advantage, is making money with our product, we should just providing the basic service, we should take some of that, and that's why they changed the license. But it's true that the open source consortium is divided in terms of whether this is considered open source or not. But in practice, you can use the license without any limitation. And then there's Minio, because on one side we have all the metadata, and then we have decided to get the documents themselves, like the PDF, the images, or any kind of document or videos, whatever we have, in a data storage, in a document store system. Now, document store is something that basically takes care of taking all documents that you just submit to it, and then it's gonna give you the option of making a deposit of the document, returning the document, securing the document, whatever you want to do behind that, and it can also just put in place the rules necessary to keep multiple copies of the documents in multiple servers, so you're sure that if one is lost, you don't actually lose anything else, without having to have an additional backup system. This is basically also the idea behind Elasticsearch. You don't actually need to back up your system or your data every day if you actually configure the system to distribute multiple copies of each document in different servers and different disks. So they basically say that their idea is to have multiple machines, but with lower requirements. So you don't need things like duplication of the disk on RAID or backups or daily backups. You can have just distributed systems in terms of one location and then copy one location to another if you want to have a fully backup system. Minio, it provides an API which is compatible. It's basically the same that Amazon AWS S3, and this is just because that's a way that they can actually plug into almost every system today. Because a lot of people has S3 as a store, a document store, so they provide the same functionality with the same API, and the switch is almost immediate from one to another. Having said that, I would say that Polaris OS could actually shift to S3, but that's not something that we have in mind, at least not for the moment. Again, Menu is an open source software with a GNU, an AGPL version 3 license. So basically, you can use it. We don't do any modification to it, so we don't actually contribute to any modification to the software itself. But if we did at some point, we would just have the obligation to send back every modification we do to them, so they can just decide whether they want to use it or not. We use a standard version. We don't change anything on it. And then there's Vue.js, which is the component that we are using, or the framework that we use to develop all the front end. And we add two small components on top of that, just to make it easy to develop new components. A set of predefined components provided by the Bulma set of components, and then Vueify that just goes over Bulma and add some additional ones and some additional functionalities. So this is all front end. So this is what we use to have a reactive front end that adapts to different formats. This is the standard way of developing web applications today, is to have a single page applications, contrary to what we had some years ago, where we had one page for each page that was seen by the user. Now today we have just a single application with all the content in it, which facilitates the communication and the data being passed between one page and the other. Let's say one view and the other instead of pages. Now the three big frameworks here: Angular, React, and Vue. The main reason why Vue is there is the first selection that was made for Polaris was React 3 years ago, a little bit over 3 years ago. But at the time, React is actually made by Facebook, or supported by Facebook, and just at exactly at the time we were developing Polaris OS, there was a change in the license of React that wasn't clear. But at some point, a lot of people in the community understood that if you made any change, or if you actually use React, anything you would do to React to develop your solution could be claimed by Facebook as their property. It wasn't clear at all. They retract from that, and it's not the case anymore today. But that made MyScienceWork change their decision and go to Vue.js, because we're just in the middle of the development, and no one was willing to take that risk at some point. So that's why we decided to use Vue.js over React. And then Angular was easily discarded at the beginning, because there was a time where Angular 1 and Angular 2, when Angular 2 was coming out, and actually everything that was done in Angular 1 would have been to be rewritten completely if they wanted to, if you wanted to have your application in Angular 2. So we said, well, if they are doing that once, they could do that again. So not a chance that we want to rewrite the whole thing 2, 3, or 4 years from now. So those are the basics in terms of the technology that we use. Now, just a word on the basics in terms of the functionality of Polaris OS. We have, and I don't think we have the time to go in details in all of that, but we have 3 basic concepts in Polaris OS. The first one is the entities, and an entity is just a unit of information. An entity could be, for example, a publication, or could be, let's say, an institution, or could be a researcher. So that's what we call entities, and the structure of an entity can be defined in a NoSQL fashion in Polaris OS using the back office. So in the application, we define each field. If we want to have objects within an object, we can define all that. We can define for each field what's the type of the field, whether we want to index or search by this field or not. And in some cases, like the date, we can define a specific format, for example, that we want to accept on those fields. And the second one is the forms. And a form is basically a way to read or to present one entity. A form is what we're going to use to ask the user to, for example, provide all the information to create a new publication. And we define in the form, again, what are the fields that we use, how they're linked to a field on the entity, what are the basic validations that we want to put in there, or if we want to link those to things like a predefined list of values. So in kind of on a drop-down list or radio buttons or some kind of predefined values. All the basic, let's say, type of fields are available, free text entries or drop downs are radio buttons, as I said before. But you can also have some specific fields that we have written for some specific formatting, like an email field or an URL that basically will make some basic validations to be sure that the structure of the data that is entered follows the standard of that type of information. And the third one is what we call the pipelines. And a pipeline is a set of actions that are going to be applied to one record when that record comes into the system or when that record is updated. So the easiest way to understand this is every time we have someone coming in, we're going to validate, for example, that all the mandatory fields are there. So that's one kind of pipelines we can have is validation validations operations. But we can also have what we call completion operations, which are going to, for example, create new fields to make easier the operations later. So we could create, for example, if we have a first name and last name as entry fields, we could create a new field called full name, which is concatenate both. We could also give some of the fields some default values, and we say, well, if we don't have this field, we're gonna give that a default value. This is basically used, for example, to create in the backend directly when we receive a record, something like the creation date of that record. We say, well, the default value is right now, and we know that that's going to go into database as the current date, and that gives, without developing anything else, the creation date or the last update for a given record. So that's the way we build the basics of Polaris OS is going to be with those three. I mean, there are some other concepts, but those are the three main ones. The entities, where we can define fields and structure. The pipelines, where we can validate how things validate or do some specific operations when the records come in or are updated, and the forms, which define how things are presented or captured using the application. Now, I think we have said now we have the basic structure and how those components are actually orchestrated in the installation itself is used in Docker. This is basically to facilitate the growth. If we need to add new power in terms of processing because of the system growth, we just need we go to the registry, we get the container, and we just add a new container into the installation. So we have all containerized, the Elasticsearch, which have each node is going to have its local storage. Same for Minio, each node is going to have its local storage. Then we have all the logic, the business logic layer, which is basically a Node.js application. So we can have as many copies as we want, depending on how what the workload is going to be that we're going to serve. Now, in the picture, we always put two at least, because we need to ensure that there is a high availability, just in case there's one that goes down. We still ensure that the other can serve all the requests. And all this is it's basically, again, just deploy a new container. Now we preset that by a load balancer, Nginx. Again, we use the open source option of Nginx. There's one that is paid, but we use just free and open layer, and then everything is designed by the Vue application on the on each of the devices. Now the Vue applications is logically served by the Node JS. So the first way the user is going to connect to the site is basically going to obtain the application, and then that application is going to run locally in the user's browser. Now, this is it's available today in the GitHub repository. There are two GitHub repositories. There's one that contains all the code of Polaris OS, of everything that you're seeing here, and then there's another one that contains what we call the deployment, which is basically the Docker configuration to deploy Polaris OS. And that's where you get the containers, and you can just, with Docker, you could launch your application on a basic configuration. Now, all configuration is on the in database in Elasticsearch. So for demo purposes, what you have in GitHub also has a basic configuration of an institutional repository, so publications and research. And datasets. Now, one thing that I wanted to show, or at least to mention, is that if you go into the repository today, into GitHub repository, there's some functionalities that has been developed in the current projects that are not yet merged into the public repository, and these are workflows and conditional pipelines. Workflows basically is a way to automate some of the actions or validations. Now, what we have as a use case here, we have multiple ones, but let's say we got two today that are clear. There's one that is the validation and the curation of research projects, basically a system that obtains projects from all around the world, and there's some people that goes into that data and has to ensure that that data makes sense for the system they're using. So they have a full process of about 25 different steps where people validate, and then they decide whether they go to the next step or they go back to the previous one, or I mean, it's a basic workflow, but every action is driven by someone deciding what's done on that step. So all this kind of configurable workflow didn't exist. I mean, it's fairly available, but not fully available in the current version that it's published, because there are some things that we are validating before publishing them. The other functionality that is on the workflows is that we can automate some actions, saying, well, if there are some conditions that are met or not in the that we can decide based on the data of the document coming in, of the metadata of the document, we could decide to make some actions or not. For example, we could say, well, the use case is in a publication control system where basically the researcher is going to say, well, here's my publication. I want to just submit that for evaluation to then publish this on a journal. The person could be using, for example, confidential data, and if confidential data is used, someone has to ensure that that all the conditions are met for the data to be published or just to be mentioned. So here we could say, for example, well, if confidential data is used, then we go to step verify confidential data it can be used. But if the confidential data is not used, we can go to another step, which is just validate the content, for example. So in this case, this decision is automatically done by the system, but based on the configuration that the user does. And this configuration is, again, done directly by the user in the back office using the screens and the pages that we provide. But this way of deciding, letting a workflow to make automatic decisions and to change from one step to another is something that is fairly new as well in Polaris OS. And then one of the actions could also be just when you get to a specific a step, for example, just send an email to someone to inform this person that things have been done, and that's part as well of the workflow right now. So those kind of things are not fully available in the current version published, but they are coming very soon because we're just testing them before getting them in there. And then the other one is to have conditional pipelines. As I said, the pipeline is the set of actions that are executed when a record comes in or is updated. And initially we had just a set of pipelines that can be executed, but they are always executed. You could not say, well, in some cases you need to execute them or not. The basic use case is, well, if you have a process with different steps, mandatory data is not the same in every step. Normally the data comes incrementally, and then you have to, in the first step, you have some data that is mandatory. Then the second one, you have everything that was mandatory in the first one plus something else, because in each step you just enrich the data. So this is something that we couldn't do before. Right now we can as well set conditions to decide whether our pipeline is executed or evaluated or not. Again, this is not fully available in the published version, but it will be very soon. So those are the main, let's say, the basics of Polaris OS. I'm getting to the end. I think there are 2 or 3 minutes left. So maybe for any questions you may have, or for more details, if you want to get into more details somewhere.
Thank you very much, Carolina and
Manuel.
Thank you for a very interesting presentation. I'm also very impressed by the diversity of the platform. I don't know if someone has a question already. Please, any question at the moment? I have a few questions anyway. First, a practical one about the entities. Entities are, in the end, objects with properties, with different parts of description. I understand.
Yeah.
Now you say you can present the entities with a form. Is it a one-to-one relation, or can you create a form where you use properties of different entities?
Now, today, in one form, you can only relate one entity. So you cannot put multiple entities in the same form. But there's there's always the exceptions to the rule, which is if you're, for example, entering data, and then imagine you have, again, I'm going to go to publications as the use case, and one of the things that you ask is the type of publication. Well, the type of publication is a list of predefined values that actually is defined in Polaris OS. That list is defined also as an entity. If you say, well, I'm going to let the users create new types if the type is not in. I mean, it's maybe not the best example, but just as an example, you can actually have in the same form a call to another form that is going to be embedded in this one, and the user will be able to open to add to add that new value as a publication type without going out of the form. But in terms of the way you configure that in the system, you actually have 2 different forms where one can call the other.
Okay. So, but I'm also thinking about the example that has been developed, for, I think, for the Deutsche Bundesbank as a quiz. How do you relate then all these entities to the serif format?
Now we have their own data structure. It's not the serif one, but yeah. Anyway, you do have multiple entities. So there's it's like was mentioned for the system before. We have relations. Actually, we have pointers to other entities. For example, in a publication, you have all the researchers that have written that publication. So you're going to have all the pointers, so IDs of the researchers. We use a technique that is used very widely in a NoSQL database, which is called denormalization. And that's done in the pipelines, which is basically every time the publication comes in, we're going to go to the researcher entity, and we're going to get the data from there and put that also in the publication record. So you can easily retrieve that information, but if you need to go to the researcher, you always have the identifier to go to the researcher entity and get it.
But in a way, the entity is a flat table, and to make links, you use these pipelines.
Now, the pipelines are used for multiple things. Now, it's not a flat structure, because you can have multiple. I mean, you can have objects embedded into a single into the same entity. Now, to give you an example, you have again the publication. You have multiple researchers. So researcher is going to be an object within the publication, which can be multi-valued, because you can have more than one without any restriction on how many you may have. The researcher may have a researcher institution he is related to, or an affiliation he or she is related to. So you can have multiple levels. There's no. It's just imagine a JSON structure, which is the standard of the NoSQL database. But there's no. It's not really flat. Now the pipelines can be used to denormalize. That's one of the applications that allows you to easily get the data into the same structure, and then where you're going to build the pages to show that information, that just facilitates the work, because you don't have to go and retrieve the other objects. You have everything in the object you have to retrieve with all the data you need to show.
So that's some solutions. So because one of the things that I see with Polaris, which is also with GISIS or JISIS in Spanish, is that it is in a way agnostic to metadata standards. Huh? In the end, you need, how do you translate it to these metadata standards? Do you have a translation, or because when you export it or when you import it?
Yeah, we don't have. I mean, the only standard we have implemented so far is the OIA PMH for harvesting,
which is only a container. Eh? In the container, you have different possibilities to work with mods or with Dublin Core or something else. Or
yeah. So the one we have implemented is Dublin Core. In effect, yeah. So the basic Dublin Core is the one that we have, because it's that was the request we had, but we mapped that to the structure of the publications and researchers in Polaris OS. We don't need to have a specific publication structure to map that to that server. Now, if you want to have, let's say, to follow strictly a standard, you may be able to just define the entities following the standard in that case. But we do not have today, if that's a question, a predefined, let's say a predefined set of entities with to initialize a specific.
It's an advantage, and it can be an issue at the same time. But surely, when you look at CRIS solutions, there it's more like sometimes like an RDF structure, and then maybe you can have conflicts. I can imagine that.
Yeah, what we have found out is that each time we go to implement what we think is a standard system, we're actually asked to add some specificities for that client, which go a little out of the standard format. So they all want to keep the format, but they all want to have their specificities as well. So we end up by having just a structure that is adapted to what they expect. And then if we need to develop specific things for APIs, let's say for publishing the information in the country systems or specific systems they want, well, we just map the that data structure to whatever the APIs ask for.
And is it? It's a JSON. It's not in a format of a triple store in the end, or is it possible to translate that also to such a format?
Now today it's in the Elasticsearch language, if we can say so. So that's basically it's a big JSON with all the mappings and the formats and the analyzers. We do not have today, let's say, a triplet that we can put up, which we would need to develop something to do that. But if you develop that, they would be always having in mind that what we would develop is a way to map a structure to a triplet, and not to develop something that it's just hard-coded. Because as you can always define the entities as you want, well, you need to be able to say, well, that interface will be able to adapt to whatever the entities are.
Okay. These are a few of my questions. I don't know if anybody else has some questions. Leandro, please.
Thank you, Mark. An interesting presentation. Really very powerful technologies. But my questions are more related to the library environment. And I have two main questions right now. The first one is somehow related to what Mark was talking about, because due to the nature of international library standards like Mark 21 and so on, it is common to have records with a flexible length. I mean that, for instance, Mark 21 standard defines around 1,000 fields or properties, something like that. But a record might include a number of them, and another record might include a different number of fields. It depends on the nature of the resource being described. So a library system requires or needs a way to deal with this dynamic behavior at the time of presenting the information. At the same time, at the time of recording the information, to avoid null values in the database and so on. So my first question would be, could Polaris OS manage this dynamic environment of library records? That's the first question. And my second question is more related to the features that are commonly present on a library system. For instance, the modules in a library system, like acquisitions, circulation, rules to manage the circulation business, which kind of object can be borrowed to which kind of user. So what could be needed in order to adapt Polaris OS to a library environment? So those are my two main questions right now.
Okay. For the first one is, can Polaris OS adapt to different type of objects, let's say on the same entity? The answer is yes. We have today, for example, again, I'll take publications as example. You can have books or journal publications or chapters or just posters, for example, which depending on the type, there's some that are requested, or some others that are not, or some are mandatory or not. Now, the way we handle that is that the definition of the entity will include all the fields of every type of publication in this example as the definition. So we know everything that we can store, but each record will get only we'll store only the values that are valid or that are submitted for that record. So that's one of the advantages of NoSQL. You don't actually need to have the same format. We do predefine the maximum format, let's say, to have the name of the fields and everything, but you are not forced to have all the values, not even on null. Have just values that are absent of the structure without any problem. Even with the conditional pipelines, you could also validate based on the type of publication in the example, which fields are going to be mandatory for a specific type as well. And you could, in this case, for the entry, build one form for each type of publication that you may have, and when the user select one type, then one form is going to be displayed, and if the user select another type, another form is going to be displayed. All this can be done in the configuration of the forms as well, because that's an interesting functionality that we are finishing testing, but we are using on the Bundesbank on the current project, which is based on the value in the form of one field, you can decide to display a different form. So this allows to do exactly on the use case that you are presenting. That's how we would handle the case of defining the structure and capturing the data, the different type of data for each type. Now, on the second question is on the modules may exist or not for a library system. Just let's be very honest on this. We have planned library system, but we have not built one yet. So there's no pre-built modules for library system or configuration, let's say, for library system that you can use. So it's similar to JISIS. You need to embrace the solution and get into the not necessarily the development, but at least all the configuration to get that done. Most of things I think are possible. If there's anything that is not, well, it's to see if there's any additional development that you could do yourself or ask us to do at some point. But today, there's no library system we could tell you, well, use this configuration, which already exists. You need actually to get your hands into the system to be able to build those. Does that answer your questions?
Most of it. Something I missed, and about the presentation of dynamic records. I mean, do you have a language, formatting language, or something like that?
we present things on the again. We are on the let's say web movement. So today we do not have a way to present something specifically in a specific format. We do use, for example, we do have a very basic language. Wow, I don't know if I call that language, but we use a tool to allow, for example, creating cover pages where you can plug data whenever you want. I mean, wherever you want, using HTML on one side, and then one tool that it's called Handlebar that allows you to extract a specific field and put that where you want.
Okay, thank you very much.
Okay, does anyone have another question? Some reaction from it?
I do. May I?
Yes, of course.
Manuel, I'd like to ask you about the systems requirements for deploying the Polaris OS stack, including the Elasticsearch and Minio, for, let's say, a small deployment.
Now, what do you in terms of minimum requirements? What we recommend is three nodes basically, where you can mix all the components. Why 3? Because it's a minimum that is recommended by Elasticsearch for the database, for Elasticsearch database, to ensure that that in case you lose not you lose one, but if you have a brain split brain situation, which is you lose the network at some point, and there's one node that is isolated and the other two that are isolated but they are together. The one that it's because it's minority, the one that is isolated on one side will not get or answer any new requests, and the other two will continue. So for that to work, you need an odd number of servers to be sure that that works well. So the minimum is to have 3 servers. Depending on how many requests you will have and how much data you're going to store, we need to size those servers. But we know that with between 8 and 16 gigabytes of memory, we can have a small, 8 gigabytes should be enough to start a small installation. And then, well, this depends on how much metadata you have. Minio, on the other side, and I see a question from Rafael that asks if Minio is mandatory and how do we deploy that. Now, you need Minio if we are going to store files in Polaris OS. If we only need to have data description fields and so on, then you don't need Minio. But if we need to store PDFs or images or videos or anything that is a file, then we need Minio. And how Minio is installed is basically, again, using the standard installation of Minio with Docker. We just use the containers that they produce themselves, and we use, as we are using small installations normally. We don't have hundreds of nodes being installed. We deploy using Docker, and then maybe Docker Swarm if we want to have some kind of orchestrator. We have some clients that have decided to use Kubernetes, but in those cases, we ask them actually to help on the deployment. When we deploy ourselves, we do Docker, and sometimes just to make things a little bit easier, we put Docker Swarm as well.
Thank you. A second question: do you provide some pre-elaborated Docker Compose file for the deployments? Maybe in the documentation.
There's a dedicated repository with the Docker files. Yeah, a Docker Composer that is going to deploy Elasticsearch, Minio, the application, everything. If you go to GitHub, there's Polaris OS on one side and the deployment of Polaris OS in another repository.
Oh, great.
we had a problem with the Docker in the way that the indexing doesn't seem correct after testing it. I can tell you.
Yeah, there's something that we have changed recently, because in that demo, what happens is that for Polaris OS to start, you need actually to have some configuration in it if you want to see the screens. You have a minimum configuration, and configuration goes into the database. So what does this demo deployment environment is that actually it's going to plug some information, some data into some configuration data into the indexes. And there was a problem because Polaris was starting before getting the data into the indexes. So we have made changes actually right now to avoid that to happen.
Okay, because it was Leandro and I tried to install it and had in fact the same problem a month or two ago. The problem should be solved in the meantime.
Yeah.
Okay, then we can try again.
But anyway, if you have any issue, just write us back and we will see together. No problem.
Okay. So, Juan, Carlos, sorry, I interrupted you.
No, it's okay. I was finished.
Okay. So, I think we finish for today. I don't know if anybody has another question.